Hi everyone, my name is Thomas Kim. Today is July 30th, 2019. This is my 28th episode about graph in C++. In this episode, we will learn how to implement std-beast. std-beast was introduced to C++ 17 standards along with std variant. In this episode, we will learn basics about how to implement std-beast. This episode is quite advanced, and you need to know what is compile time loop. For more information about compile time loop, please double-click this link. By watching this video, you can learn what is compile time loop. You also need to know what is std variant, how to use std variant. Please double-click this link if you want to know or learn how to use std variant. Also, you need to understand the concept of Mixin. So if you want to know what is Mixin, please watch this video. Also, you need to know what is type list and container of variance. Please double-click this link. As I said, this episode is quite complex and very much advanced. Without further ado, let's get started. Start Visual Studio Code. Under CPP extension, select Graph folder. Click this button, 28 beast.cpp. Hit enter. Ctrl V. Include talkplay fun, output HPP, talkplay fun, access stream, auto, and talkplay fun, and we will define a namespace, talkplay fun, types, end of namespace, talkplay fun, types. We are creating a struct, template, size t, start index, size t, end index. Struct, compile time, loop. Don't forget semicolon here. End of struct, compile time, loop. We create a template function, template, type name, visitor, type name, variant, type, static, void, beast, variant, visitor, beast, type, r-value reference, I say visitor, variant, type, r-value reference, variant, I would say BT. So this is static member function returning void. In this scope, we call this function, I copy this part, remove static, and rename the function beast. From this variant type, we create a new type alias using variant t. We remove constant reference from variant type. Remove cb reference t variant type. From variant type, we can get the size. Context field, size t, size, std, variant, size b, variant t. About this function, please refer to this web page. I will put the link here. Now at this point we have variant size. Now we call this function like this. The start index is 0. The end index is size. I say variant size. This function is template. We pass visitor std toward visitor type visitor. The second parameter is variant type std forward variant type vt. So we are calling this function. Now here, if context sphere start index is this index is less than end index, if auto ptr std get start index, it should be get if. We have to pass address of variant. If it is true, this is pointer. If successful, it returns pointer. Then we call visitor. ptr. But this is not good enough. We say std forward visit type. We typecast first. Then we call the function. Then we return. At this point, if context sphere start index plus 1 is less than end index, then we call this function recursively like this. We copy the containing class start index plus 1 end index. This is template function, so template. Now we call this function. It has two parameters. The first is visitor std forward visit type visitor. The second parameter is variant std forward variant type vt. So this is recursion. This is called compile time loop. So this is how we defined visit. Now let's see how to use this. At this point, namespace types talk play fun types. This is namespace alias void test visit. I say visit basic int main. I will call this function. Let's build this function first. If it works successfully, start command prompt. You should be in cpp extension grep folder, g++ std c++ 17 28 visit.cpp, hit enter. Visit type has not been declared. This is visitor type. I fixed we also have to fix it here. Okay, everything seems to be fixed. Now let's build once again. Okay, everything works. Right before the end of namespace types, here, template, type name, visitor types, struct, overloaded, public, visitor types. Don't forget semicolon here. This way of programming is called Mixin. We create a constructor overloaded visitor types visitors. This is base class visitors. So we created a constructor after the function block. After the struct, we define template argument deduction guide. I copied this part, overloaded visitor types. This is constructor specification, overloaded. This is type specification. I fixed the typo. This is so-called template argument deduction guide. This feature was introduced to C++ 17 standard. With this, using name t constant character pointer, using age t int, using weight t double, we define variant using variant t std variant name t age t weight t. We define the variant type using container t std vector variant t. We define the container type of vector of variant container t info in place back. We can provide Thomas Kim info in place back 30 info in place back 65 info in place back Sophie Turner info in place back 20 info in place back 56.7. Now we placed some data. Now we define overloaded. We use this construct types overloaded handle info. Please note that this is constructor specification. We are initializing this element. We create here talk play fun stream auto and there talk play fun and there we capture stream also capture and there we use this type name. We will use r value reference constant name stream name is name and there we provide another one stream and there constant age t reference age stream age is age and there stream and constant weight t reference weight stream weight is weight, and I will define one more for catch-all stream, and we can just say auto value stream unclassified, and we can print out type talk play fun get type category value, and this is for catch all if failed. We defined overloaded. Now here for auto p info overloaded, we are calling function call operator. I missed one thing here using visitor types operator. Now we pass p. Sorry, not this one. We have to call this an instance like this stream, and now let's run it. Hit enter. Sorry, I made a mistake here. It is not here but here. I fixed. Hit enter. Okay, it built successfully. Please note that unclassified. This function is called. I made a mistake. I will delete this. Types beast. We are calling this function. So it take handle info p. I would say vt for variant. I modified like this. Let's build once again. CLS still unclassified. Type is constant character reference. Int reference, double reference, but we specified constant. So I will change it to constant ref. Okay, then I copy once again. The reason I copy once again is I'm going to recycle it as reference. Then I remove reference here. I remove reference, then I copy it and I paste it here like this. Now let's try it. Build once again. CLS. Now it works perfectly. I will copy it once again. Copied. Stream, and now this time I will copy constant. I will put it constant. Now I will make it constant. CLS. Now everything works fine. Okay, in this case we are handling element of variant. In this case as constant. In this case we are handling as reference. So this catch-all is very useful for debugging purpose. Now I copied this part of code. I copied it and pasted it here. Now I change it to std C++ standard libraries beast. Okay, I also change it to C++ standard libraries beast. In the command prompt, we build once again CLS. Now everything works. So this C++ standard library beast and my own implementation beast work exactly the same. We learned how to implement std beast in this episode, but there is one problem in this implementation. This implementation, std beast, has one drawback. I will talk about this, the limitation of std beast, in my next episode. I will upload complete source code to my website, extensiontalkplayfun.com. By the time you watch this video, you can download complete source code by clicking this link. And if you unzip the downloaded file, under CPP extension grep subfolder, you can find the complete source code of this episode. Please subscribe to my YouTube channel. Thank you for watching.